Lesson 865, Fit Fights, Fitting a Line to Data. In this lesson, we'll fit a line to data shown in a scatter plot and also describe features of a line that fits data well. We're on page 78 in your notes. And our goal today was to draw a line to fit data in a scatter plot. Draw a line to fit data in a scatter plot. And also, describe features of a line that fit data well. Describe features of a line that fit data well. So it takes a little practice to draw a line of fit that we can use to predict data that's not in one of the points. And that's what we practiced in the activity today. For any given data set with a linear association, suggesting that we can draw a line through the data, there are infinite linear models we can draw. So how do we decide what linear models are good fits for the data? So for example, we have a scatter plot here, and there's a bad line that's been drawn that we'll discuss in just a moment. But what makes it a bad line? How do we know that the line's supposed to look like this? Why can't the line look like this? Why can't the line be down here? Why can't the line look like this that works with the data? And there's some specific things that we're looking for when we do draw a good line of fit. So here's a data about the price of a used car and the year that it was manufactured. So we have these newer cars from 2016 that cost, it looks like they cost more the newer they are. And the older the car is, the less it costs and the less it's worth. So that's what our data is about. And each one of these points represents a car, and we know two things about the car. We know the year it sold and how much it sold for in dollars. So Sanvi drew this line of fit for the data. Okay. Now, she might have chosen to use this line of fit for any number of reasons. It's not a good line, but maybe she chose it because it passes through the points that are kind of farthest to the left and farthest to the right. And she thought that that was a good way to decide what would be a good line of fit. Maybe somebody else would choose the oldest car and one of the newest cars, thinking that that would be a good idea. Maybe somebody chose the least expensive and most expensive car and thought that that would make a good line of fit. But just basing your line on 2 points, left and right, oldest, newest, least and most expensive, that's not really what lines of fit are all about. So let's talk about why she might have chosen this line and why it's not really a good fit. Maybe because the line passes through the points farthest to the left and right. On the scatter plot. Well, the reason this is not a good fit for the data, for one thing, it looks like most of the data is actually sitting below the line. This line really represents very few of the data points. So that's one problem. Most of the data is below the line than above. Okay. And this line, if we used it, would overpredict most of the data. Let me tell you what I mean by overpredict in a moment. The line would overpredict oops, let's see, most of the data. A line of fit is there so that we can make some good predictions about data that's not actually part of the set. So if I had an input of 2010, and I wanted to predict the cost of the car, and I came up to this line, this would really over-predict the cost of a car that was made in 2010. The cost of a car that was made in 2010 would probably fall in line better with these other points. It'd probably be a lot less expensive. So it would over-predict most of this data. So let's go ahead and try and draw a linear model that's a better fit and explain what we did to make that happen. So let me get a green line here, a green highlighter. I noticed a couple of things about the data. It seems to have a positive trend. So I want my line to also have a positive trend, kind of to fit in line with this data. And I want to fit my line so that it follows the trend of the data, and about half the points fall above the line and about half the points fall below. So I think I've got it positioned about like I want it. I'm just going to draw this line of fit that I could use to predict the cost of a car from any given year. So I don't actually have a car from 2010 in my data, but this green line would help me to predict that it would be probably about $11,000, maybe $11,500, between $9,000 and $12,000. But the original line would really over-predict that. Now, the way I chose to draw my line is I followed the trend of the data. I followed the positive trend of the data. And about half the data is below and half is above the line. So just getting half the data to fall below and above the line is not quite enough. I mean, I could put my line like this with a negative trend, and half the data would be on one side and half the data would be on the other. But it's really important that it follows the positive trend of the data. So the slope of Sanvi's line wasn't bad. It's just that it sat too high. Okay? We want about half the data to fall above and about half the data to fall below. So to finish up, if I wanted to describe some characteristics of a line that is a good fit for the data in a scatter plot, I would say the direction or the slope of the line matches the trend of the data. We'll talk more about slope in coming lessons. Matches the trend of the data. And that's something you just determine visually. Secondly, the line passes through like the middle of the data. So that like half is above and half is below with that trend line. And the points are as close as possible to the line. That's kind of pulling together both of these things. As many points as possible are as close as they can be to the line. So those are the features that we'd like for our lines of fit to have.